Hi everyone, welcome back to our channel. Today we are going to discuss about brushless DC motor used for electric vehicle applications or hybrid electric vehicle applications. So now coming to the parts of an BLDC motor. So basically this BLDC motor we are going to have two parts. So already we discussed we have rotor and we have the stator. Okay, so in a DC motor this rotor is made up of a winding where this winding is called armature winding. So what is meant by an armature? So armature is nothing but set of conductors, and you are going to have the stator where this winding is called field winding. Okay, so now you can see here this field winding is generally an electromagnet in the case of an DC motor. So we have to give the DC supply which is self-excited or separately excited, and this electromagnet we are going to convert into permanent magnet. This is the original brushless DC motor. Okay, you can see this brushless DC motor. So this is nothing but your rotor part, and this is nothing but your stator part. In the rotor you are going to have the armature winding, and this armature winding we are going to have some set of conductors, and this is nothing but a stator part. On the stator part you are going to have a field winding. This is nothing but the field winding, and this field winding we are going to replace with an permanent magnet. So here this constitutes the armature winding. So this is generally the concept of this normal brushless DC motor. Okay, so on the shaft of the rotor we are going to have the Hall sensors which is used to detect the position of the rotor with the help of a stator. Okay, so that is about the Hall effect sensors. So these sensors will be generally mounted on the shaft. This is used to identify in which direction, I mean the production of flux. But originally when you come to this ceiling fan type BLDC motors, so here also you are going to have two parts. So this is nothing but you are going to have stator as well as rotor. Okay, so this is nothing but our stator and it is enclosed with rotor. So here the concept is the rotor will come out. So this is nothing but our rotor and this is nothing but our stator. So here the parts are reverse, or the parts are similar to that of an synchronous motor. So in the synchronous motor, on the rotor you are going to have the field winding. So generally we have electromagnet field winding in the case of synchronous motor also, but in the stator part we are going to have the armature winding. So already I told what is meant by armature. Armature is nothing but some set of conductors. Now see here, I am going to bring the rotor outside. So this is our rotor, and this rotor, rather than using an electromagnet, I am going to replace this electromagnet with a permanent magnet. With a permanent magnet, by using permanent north poles, and so this will act as one north pole and this will act as one south pole. So based upon this permanent magnet, it has a lot of magnetic strength to produce the flux, and this rotor is nothing but of permanent magnet, and the stator you are going to have the armature. So you are going to have some set of conductors, and here you are going to give the phase as well as the neutral. So on this shaft you are going to have the Hall sensors. Okay, so here you have some Hall sensors. So in the electronic board you can see here. So here we will be having some Hall sensors. This Hall sensor will sense the position of the rotor and adjust its EMF, I mean adjust its voltage to be applied to the a set of coil. So that is all about you can see here the parts, I mean the parts what we studied in an ceiling fan, BLDC motor are similar to that of an synchronous motor. So synchronous motor is reverse to that of an DC motor. So this is original DC motor. In this original DC motor, what's happening here? So here you have the rotor. Rotor is made up of what? Armature. But here the rotor is made up of field winding. So this rotor is made up of which winding? Field winding. But field winding we are going to replace and convert into an permanent magnet. And you are going to have the stator part. On the stator part you are going to have the armature. This is nothing but the armature winding, and on this rotor you are going to have some Hall sensors. These Hall sensors will help us to decide which coil has to be energized based upon the position of the north pole or south pole, which are permanent magnets on the rotor. This slide can crystal clear about the parts of an brushless DC motor. Now coming to the concept. So the advantages of this BLDC motor is, so we are going to have a permanent magnet. When you have the permanent magnet, the life of BLDC motor is of higher value, or these BLDC motors are having higher reliability. They have high reliability or higher life. They can able to produce high torque. Okay. So generally how the formula of torque is directly proportional to some flux into Ia. So here this flux is nothing but produced by the permanent magnet. It is of full magnitude or full amount. Automatically the torque produced is also maximum or larger amount. And the next important point is, so the conduction of heat through the frame. You can see here the heat conduction is, the heat can be easily conducted in this stator part. The conduction of heat to the frames is improved in the case of an BLDC motor. The next important point is the conduction of heat is improved. If the conduction of heat is improved, automatically it can take required amount of power. Conduction of heat is improved through the frames, and due to this conduction of heat, it can increase the electrical loading on the fan, and which leads to higher power density. So where it can have the capability to carry high power density. So power means watt, density per meter cube. So for a given volume, it can carry higher amount of power. I mean automatically the load carrying capacity or the power density of the motor is higher. So automatically for a given area it can carry more power. Automatically what happens is, so this comes with lesser weight. So the conduction of heat is improved, and due to improvement of conduction you are able to load this motor with higher current rating, and due to this loading the power density of this motor is improved than compared to the remaining parts. And already I told, this BLDC motor have the capability to operate with shaft position sensors. So on the stator we have the Hall sensors. So by using these Hall sensors, they can identify which coil of segment has to be energized. This is all about the brushless DC motor. So now we are discussing about this Hall sensors, where these Hall sensors also have lot of issues. We require, so this undergoes a mechanical vibrations, and we are, the latest technique is we are having sensorless operation. So we have sensorless operation. So this Hall sensor may accumulate with dust, and this undergoes a mechanical vibrations. So after 1 or 2 years, due to mechanical vibration and dust, the life of this Hall sensor is going to decrease. Therefore the complete R&D is happening to replace this Hall sensor with a sensorless type. Okay, so sensorless control technique is also developed in the power electronics at Texas. So now, so this is all about the brushless DC motor. So we will meet in the next video to understand about how switched reluctance motor are useful for electric vehicle applications. So thank you for watching. If you feel the content is useful, please like, please share the content with your friends, and please subscribe our channel for more updates. And if you have any doubts, let me know in the comment section. I can answer your doubts. So thank you for listening patiently. Yours obediently, Ram. We'll meet in the next video of switched reluctance motor. Thank you.